Right, let's see how we can ramp up this music. There we go. Hello, explorers, and welcome to Reach the World's Explore program. For more than 25, oh, hold on a second. There we go, all fixed. Hello, explorers. Let me start again, and welcome to Reach the World's Explore program. For more than 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and we're back with another amazing chapter in our Supercomputing and the Future of AI virtual exchange journey. Joining us is Dr. Braulio Villegas, Associate Professor at the Autonomous University of the state of Morelos in Mexico, and Visiting Professor at Loyola University in Chicago. He is joining us today from Cuernavaca, Mexico, and he is going to tell us all about quantum computing. We have covered research software engineering, we have covered supercomputers, and now we are looking into the future by talking about quantum computing with an amazing expert. I'm so excited to learn more today. I want to share a friendly reminder with the more than 850 students in 40 classrooms across the country who are following this journey live. There is a great selection of articles on the Supercomputing and the Future of AI Journey homepage. I'm going to add a link to the chat as soon as we get going here today. You can visit anytime. Make sure you check out those articles, and you can learn more from Braulio and others who have participated in this expedition. And I think that without delay, we need to dive right into the world of quantum computing today. So I'm going to go ahead and welcome our special guest, Dr. Braulio Villegas, and let's bring him onto the screen. Here he is. Welcome.
Thank you, Tim, for the invitation.
It's so nice. It's so nice to see you. It's so nice to welcome you. I know that we have the students and teachers and classrooms who've been following this journey have learned a lot about computing generally in the last couple of weeks by meeting a bunch of the people you know as well in this field. And today feels like we are like summiting Everest in the world of supercomputing by starting to talk about quantum computing, which feels very futuristic and the future of quantum computing. So without delay, I'm going to turn it over to you. And we would love to hear all about you and your work and what you do with quantum computing.
Thank you for the nice presentation. Okay. Hi, everyone. For how Tim already said, and that's for the nice presentation. I'm the Professor Braulio Misael Villegas Martínez. So today I will be talking about the quantum generation. This is the building the future with qubits. I will make a bit introduction what the qubits are, what is the future about quantum computing, because it's a multidisciplinary field. And I will let you know more about myself and what is the research line that I'm working on at the moment. So, how I already said, Tim, I am an associate professor in the Center of Engineering and Research and Applied Science, and mostly on my time is not only focused to make research. Also, I had a free time to make explore, catch nice good ideas to try to make some adrenaline sports and adventures. Because when you are focused too much on your work, you need to get some more inspiration. So if you have more inspiration and you can make what you work, you can find some novelties and new approaches how to solve a specific problem. See it from a different angle, how we say here between my colleagues.
Can you tell us what we're looking at in these two pictures? What are you doing in these two pictures?
Oh, yeah, there's a long history behind these two pictures. And the picture on the right side, it was around 2020 during the COVID pandemic. So we had a chance to go to the Chicago aquarium. We realized this kind of activity to touch the beluga whales. That was fantastic. Even I can say one of the beluga whales that had this kind of activity, they only had at this and in their mouth, only pushing and throwing with the head. So it was amazing because one on this almost touched part on my head. So that was a venture. For the left side, it was a celebration that we make with my entire family. because during the same year on 2020, one of my uncles passed away. So we had to celebrate in Mexico. Mostly we celebrate when someone, mostly lovely family members gone to this world to another. We're trying to make like a not a celebration, but this like a remind me what the most member on the family likes to do. So it was part of the family member celebration. No celebration, so sorry, say that. But it was to remind me that someone on the family member really passed away, and he's now in a better place. It's part of the Mexican.
Wonderful.
So passing for the second slide, this is the place where I'm working at the moment. It's the Center for Research and Engineering Applied Science. So it's locally in 2 hours from Mexico City. Cuernavaca is the place where I'm living. And the meaning of Cuernavaca is this eternal spring, the eternal spring, because mostly on the fourth season of the year, we always reach temperature between 30 and 35 Celsius degrees. So we have a good weather almost the entire year.
Excellent. And you, that is where you're based, but I know, and we said in the introduction that you come up to Chicago quite a bit. Is it part of your work that you get the opportunity to travel around and teach and learn about the topic of quantum computing in different countries?
Oh, yeah, absolutely. In fact, I forget to mention that in 2020, I had the opportunity to join to the Notre Dame University in a small quantum computing group. And after then, I was trying to switch and check it out what the other opportunities are open in the USA country. One of them is from Loyola, because it are very interesting to create the first quantum computing group for undergraduate students. So trying to join the computing science department and the physics department also, and try to make this score for the fall on this year. So it's a part of a collaboration to try to implement what it will be the lessons to teach to all the students. It's not only for those that had a strong experience in physics or mathematics. It will be a multidisciplinary course for everyone who will want to join.
Okay.
So yeah, it's an opportunity that we're working now with Loyola University.
And before we get too much into quantum computing specifically, how did you get interested in physics and mathematics and quantum computing? When you were a young child, did you just love science and math and you knew that this was going to be your career path, or did it come later?
Oh, that's a very interesting question. Since I come from a small town, specifically there, the chances to really know about how the nature behaviors was very, very, very tiny. So I really had the opportunity to get so many scholarships to go to the main capital of my state. That is not too far away from Cuernavaca. It's around 8 hours. And after then, I joined to the physics faculty because when I was a child, I made so many questions to my parents. I would say, okay, what is happening with the light? Why is a drop of water thrown to the stand and create this kind of, bright and darted sounds? So I'm really there in the faculty of physics. I know a really good professor, and he tried to explain how the lights behave in a small scales. And for me, it was very interesting to ask him directly to hear how we really can manipulate some particles only using lights. So mostly my work was concentrated to something that is called now optical tweezers. That means you had a beam line, and with that beam line, you can collect a small particle and move it. So that was completely attractive for me when I was in the bachelor degree. After that, another question emerged. Okay, here we can manipulate this small particle with lights. The influence on the environment, we play around on it. So with that question, I really had to say, okay, now I have this especially requiring all the skills about you move all the equipment, but I need to understand a little more. So I make a big transition for be experimentally a very young age to the theoretical part. And after then, with all the theory behind about what the open systems, that is the system that interact with the environment, I can a little more. And after then, when I go deeper, I find the work on quantum. So mostly all my research was concentrated on the first instance in theoretical part. And after then, in 2020, it was what the quantum computing boom, this high confront for everywhere. So my first reaction was, I want to be there. I want to be there because I want to implement all the theory that I learned for all these couple of years in actions, in real problems.
Okay, excellent. What a great introduction to quantum computing itself. What is quantum computing?
Okay, quantum computing, we can define it in a simple sentence. Quantum computing is a multidisciplinary field that is part of the branch of computing science because we use the important behaviors on the quantum mechanics. And the three important behaviors on quantum mechanics is something that we call it like a superposition, entanglement, and interference. So to make this more simple, mostly on this cell phone that we use to send a message or the computing that we're working to write an email are working in a large sentence between zeros and ones. So every time you write, hey, hello, how are you? It's a large sentence, zeros and ones, and you have to write the zeros and ones for in a single step. I mean, by one. So in quantum mechanics, we have a property that is called superposition. That means you can have two states, and we make this analogy with a coin. So you have the possibility when you throw out the coin through the air and collapse in your palm or maybe on the floor, you can collect one result. Could be head or could be head tail. In quantum mechanics, we describe this kind of situation in this small world by wave function. That's wave function collect all the information for this example, all the information about the coin. So the coin could be tail and head at the same time. So that is one part on the properties about quantum mechanics that we use in quantum computing. Why is important? Just trying to remind that I really had a book. In this book, I put a separate message, and put this book in a big library with 100 books, right? So here we use we use a classical computing. We had to read to every book a single time. That means I need to open every book step by step and trying to figure out where is the secret key on it. Well, in quantum computing, using this kind of property for quantum mechanics superposition, I can open the book, open and close it at the same time, and can reach to the solution immediately.
Okay.
The other property that we have in quantum computing is entanglement. So, how already say in the previous example, I had a 50% 50 chance to get tail on head only the coin. But quantum entanglement means that we have two particles that are really connected to each other. It doesn't matter how far away they are. So, in that example about entanglement, try to imagine that I give you a coin to you and present my coin to me. And we have this special quantum property that we call entanglement, right? So in this case, how really an entanglement, here I can flip the coin in the air and make the measure and see that it's tail. I can immediately know what is the state that you have in your coin. That's mean that will hit. Because exists a big correlation between these two coins. So quantum entanglement really use this kind of quantum computing. You really use this quantum property.
Okay.
The other is the
good.
Yeah. No, go ahead.
No, I was just going to say, I remember very well being in math class as a young person, and you're learning about probability, and you're flipping a coin, and you're counting how many times is it landing heads, how many times is it landing tails, and those are the only two options, right? It's either heads or tails, and that's the information you have to work for. But I think, tell me if I'm summarizing correctly, that there are other options in quantum computing. It's not just heads or tails. There are in-between options or both at the same time.
Yeah, there are so many options because a qubit is specific or defining like a two-level systems. He would say that for example, in the macroscopic level, the cone could be a specific cubic because you had only two choices. So a quantum computer really worked with several qubits. And these several qubits, they had two choices to show. That does mean, for example, for the light, the lasers that we use in laboratories, we can define a specific how we say, property that is called polarization. That means that lights propagate in this form, or in vertical or horizontal. So the light could be react like a qubit because only we had two possibilities. The other thing that I forget to mention at the beginning is when you realize a measure, we contextualize what is the possibility to get the vertical polarization or the horizontal polarization. So we need to make a lot of measure to make a statistic or a histogram to see the 15 or the 50%. Until now, there are so many companies. There are so many companies that offer these cloud servers really to raise to quantum computers. So in this slides, we can see the main difference. For the classical bits, only we had a 0 or 1, but for the qubits, we can both 0, 1 at the same time with the 50% bit 0, 50% to bit 1. And this is, thanks God, for the quantum property we call it superposition. Okay, so how we really define what is a qubit that is a two-level systems? There is a lot of companies that implement their qubits. For example, IBM working about supercomputing qubits. That means this is a kind of platform where the current can flow with any resistance. That means we are working with electrons. Xanadu are working with optical quantum computers. That means they're working with lasers and where we can spin this property for the light that is the polarization. That means we can have the polarization in vertical or horizontal. We had only two choices. Google and CERT, they had another kind of qubits. Every of these kind of companies offers open source tools and hybrid models. What does this mean? For example, you had the qubits, you had the quantum computing, you had the chips, but you had to translate the signal of how you measure when all these kind of qubits collapse. So we need to race to the classical thing, because how the qubits are in superposition, and after that you make a measure, you have to store that information in a classical bit.
Okay, and is the whole goal of quantum computing to make computing even faster, or is there another benefit of thinking of computing and approaching computing this way?
Oh, that's a really good question. In fact, we not expected that the quantum computer really replace the classical computing. We expected to complement each other, because there are so many problems that classical computers that cannot solve. For example, for simulate the specific molecules. So how we are trying to simulate the specific molecules, we need to model the nature using a quantum model, right?
Mm-hmm.
In this case, how I mentioned before, every time that we make a measure of the qubits, we had to store it in some part. So we need to use also the hybridization about using again the classical computing. The other thing that is also very important about the quantum computer is the quantum advantage. Maybe all the news we hear about the quantum advantage, that means that we can solve a specific problem that a classical computer can do. Well, there is a big competition, because science is always focused in make hypotheses and try to really reach about this hypothesis is true or not. And is not trying to make a better model about the previous hypothesis. So in the quantum advantages, there are some reports that, for example, that the factorization numbers, there exists an algorithm that call it short algorithms that can factorize certain numbers more faster than classical computers.
Mm-hmm.
However, this is not completely true because for factories a big number, we need a certain number of qubits. So in that sense, every time that Muslim researchers present their solution that, oh, we find a quantum advantage, is because they not solve a specific problem. And no, only demonstrate, and maybe for the optimization, maybe the time that it reaches to solve the problem in a specific, or the other that could be solve something in the algorithm that's more efficiencies than a classical algorithm. So it's a big competition because every time that someone show, okay, we are raised a quantum advantage, there will be the other guys that work in classical computing, they're trying to improve the classical algorithms and trying to see, okay, we now in the same stage. And this is process, it will be a cycle, it will repeat. They're trying to prove the quantum advantage in the classical computers, or the classical research trying to, demonstrate the opposite. But they
Is it
complement each other.
Is it the same for you that it's the research software engineers that really help harness this computing power, that you need specialized software and research software engineering to really harness the power of a quantum computer in the way that we've seen on this journey, this learning journey together, that it really is what allows scientists to access the computing power of a supercomputer? Is there a special coding or software that is required to tap into the power of quantum computing?
Oh yeah, there's exists many quantum-baked or quantum libraries. For example, ABN offers the Qiskit library. This is a very open source, and there is a big community. They always trying to make a lot of repositories about how to implement certain specific circuits or certain specific quantum protocols to solve something specific. For for Google Cloud offers years, that's another different quantum library, but mostly of them offers the cloud. That's mean they offer the quantum libraries that you can run this nice, or you can create your quantum gates and your quantum algorithms locally on your computer, but only we have the limitation that will be like a simulator, right? Mm-hmm. That's mean that will be very ideal and you get very ideal results. However, when you run the same algorithm through the cloud connected to real quantum computing, you get some not a perfect results, because how I mentioned at the beginning, the qubits, trying to keep ideal qubits, does mean we trying to eradicate any interaction with the environment. And this is impossible because the qubits are very sensitive. So in that case, there are so many people that are working on how to mitigate all the errors about this kind of result through the qubits.
It sounds like it's a constantly developing sort of cutting edge process that is being figured out and added to and shared by lots of people around the world who are working in this newish technology.
Yeah, there's a lot of work behind. We have the infrastructure about the hardware, how, because one of the problems about the hardware is he will create the chips with so many qubits. The qubits will interact actually with each other. And all these kind of qubits also interact with the environment. That will be very sensitive. He interact with the environment, we get some noises results. So there is a part about the software, about the hardware. There's the other part about the software that trying to optimize the algorithms to really implement a specific problem, and how they reduce the time, or maybe how they reduce also the or mitigate the error, because we had to, yeah. So sorry.
Well, I want to. I'm intrigued. All of this is very intriguing, but I want to learn about the Axolotl student chapter. How are students involved in this quantum computing, which sounds very complex? How do students who find computing on this level and these sorts of challenges, how do they get involved in this exciting field?
Yeah, this is a really good question. since returning back for all the knowledge for the quantum computer from Notre Dame, and after then I was, calling for this university. I contract like as a professor. I noticed a really big gap. The Muslim students, they don't have any knowledge about what is quantum computing, and make my own receipts between all the coolies that reside in other parts of Mexico. And quantum computing is not a big background here in Mexico. So I decided to create this actual student chapter that's completely related with the Optics Photonics Society. And after that we created, we tried to focus to really about the quantum computing application, specifically in quantum computing algorithms or programs. So mostly of my members that we can see in the picture on the left, it was for around 1 year ago. We really funded the student chapter, and during that period, we created the first quantum computing workshop in February on this year. So really, the John Severus Quantum Student Chapter, the Optical SPA around Mexico, and we invited several speakers for USA, United Kingdom, to provide the knowledge and what is so important to be involved in quantum computing today.
Excellent.
And for the sorry.
That's okay. I'm just trying to keep you moving because I know we're short on time.
Yeah, I know. Okay, that was the first perspective. Okay, let's create a student community, and this is the community how we can be involved about quantum computing. But to be involved in quantum computing, we need to make these hard concepts about quantum mechanics more easy to understand for the general public. So mostly of my students really create, this is a really fancy quantum fold explanation about the concepts, because something that I forget to mention, this is my cartoon that you can see on the right side on the quantum phone represent a very specific animal that we have here in Mexico. So we say, okay, how we reach to the young public? Let's make it more funny, more colors, and we need to explain more for children and maybe some for secondary or elementary school. So how they say, you can see the little the little pink guy. So this little pink guy that's doing this kind of thing represent the entire information how feel this little guy. For example, in the first instance, he's sleeping, and they had an alpha. That's a parameter to say how much this guy going to sleep. The other contribution to the left side on the plus sign is when this guy feel very energetic. So it's similar to have a qubit and the coin. So every time that we make the measure, we have the probability that we get that this little funny cartoon be very asleep or be very active. So how we can measure this? Through the blush sphere. The blush sphere is a physical and mathematical representation about where is the qubit is. So on the top, say that it will be an anxiety level that corresponds when the cartoon is very energetic, and the some pole that means when the guy is sleeping, when he is rest, that we call in the basis state. So this blush sphere represents about rotation in the blush sphere. One blush sphere represents one single qubit.
Okay.
So the other thing is about the representation about the circuits. How already say, for example, decades. This is the direct notation. How we represent the states in quantum mechanics. Also here the states about the quantum computing. The zero represents when is in the basic level. That means when the cartoon is sleeping. Okay. So every time that we apply a gate is a simple rotation in the sphere. It's like give a certain energy to our cartoon, and who will decide what operation will we do, how we modify his states about the pink guy.
This is sort of calls to mind that there's a special language for this field that you're explaining very well to us, and you've made really fun with these illustrations. But it sounds like being in a world of quantum mechanics and quantum computing is like learning another language as well, because all of these signs mean something very specific to you that they may not mean yet to us. But this is telling a story, what you're sharing here.
Yeah. There is a lot of concepts of mathematical formulations. Part that we're trying to make here is trying to explain this is harder formulation in a simple manner. For example, how we say here, trying to really reach to one result, how this little guy feel sleeping or very energetic, is only make a measure or a representation. That means in a simple case, I don't have a box limits. Yeah, it's more practical. So these two guys represent, when I take a look, is a make a measure. How is my animal is very active, is awake, or maybe is asleep. Mm-hmm. So this is the manner how represented in quantum mechanics. But for this we call it a bracket, and the other. Sorry, this is a cat, and the other represent a bracket. I don't know if he can see my pointer here in the slides, but
great, very cool. Thank you for explaining that to us. Let's keep moving.
Yeah, sure. So after that, we really found in the student chapter, we was working with several coolers around the several Mexican university and some partners in the USA, and we focus and say, okay, how we can reach to a young public and make more easy to understand how these circuits work and algorithms also well. So in that case, we found Cubicle. Cubicle is a platform that really is working in Jupyter notebooks, and there are specific step-by-step algorithms how to create it from zero. So we have there a specific tool that we call a QInterpreter, because at the beginning on the presentation, I really mentioned that several quantum companies offer diverse quantum libraries. And these quantum libraries, there are specific rules how to run in the algorithms on it. So we come with a good idea, one of the students that graduated 1 year ago, that say, okay, why he will implement something that Gulliver has? And asking directly, what is the idea? Gulliver had a translator that he put a word in English, translate in Spanish, and from the Spanish to German. So let's do the same with these 5 different platforms for Google, for Amazon Bracket, for PennyLane, for AQM, and for Rigetti Quantum Computing. The 5 have different quantum language and how programming the circuits and running in a quantum simulator. Because we had someone that is expert in ABM. I want to see how the circuit looks for Amazon Bracket, and they had no any knowledge. They were very useful for him or for her. So that's what we're focused during 1 year to develop this quantum interpreter. And after then, we created the first quantum computing workshop. It was a really good opportunity to talking about the quantum interpreter is very functional and only like a simulator level. And also to join the other Mexican university to really move forward about the quantum computing field. This event was in February of this year, and we are planning to make a hackathon. And in this case, now we are really prepared because we try to interpret to really get meet a lot of users, and this a lot of users can run all the algorithms over there.
All right, excellent. You cut up with the audio for just a minute there, but we're on our final slide of key takeaways about quantum computing.
Yeah, you can hear me, I guess so.
Yes.
Okay. So mostly you may be asking themselves, why quantum computing is so very important in this moment, and why take a big impact in the next years? all I can say in your manner, the quantum computing
Braulio, I'm going to stop you. Sorry to interrupt you, but oh yeah, it looks like you dropped eventually. The connection's a little patchy, and that's okay. It happens from time to time on Reach World. Braulio, thank you so much for taking the time to join us. As he works his way back to us, I can just maybe summarize some of the takeaways thanks to this wonderful slide. That quantum computing is complex. It is a constellation connecting lots of different things. It is an emerging field for those of you who really like supercomputing and are interested in the future of computing and the future of problem solving using these very complex evolving technologies. That it's not all that different from other Reach the World Explorer programs, in that as long as you are interested in learning and exploring and trying out new things, you may want to apply your talents to the quantum computing field and be like Dr. Braulio and be a part of this very exciting sort of peak frontier of technology. I know from speaking with Braulio that he works with a team. He works very closely with others all over the world to come up with new technologies, new solutions, new ways of thinking about things. So it is a very global career in that you and he and anyone else working in quantum computing will want to be able to work with and accept and process the perspectives of others. I see him arriving in the backstage, and I'll welcome him back.
Oh, sorry, technical issues.
No problem. So, I was giving my own sort of summary of your takeaways here, and maybe you can give us in the next 30 seconds your own interpretation and see how I did.
Yeah. Okay. So quantum computing is an important field, and there's a lot of opportunities most young people can reach in the next coming years. Why? Because we need engineers, we need computing science for improve the algorithms, engineers for this software thing. We need people that we can teach quantum computing to others. It's in quantum education. And for all these requirements, only I can say two important things. You should work in team. That is very important to transmit the knowledge to someone that is not involved about physics, mathematics, or all the field concerning to quantum computing, like a computing science. And after that, trying to create a big network. A big network really had a big impact in communities. Believe me, you can change the lives for others, teaching the topic and bringing to them other opportunities to open to them to go to other places.
Well, Braulio, thank you so much for introducing us to the amazing world of quantum computing. What a fascinating topic. I get the feeling we could talk for hours about this topic, and that you're taking a lot of information and condensing it into a very brief description for us as our first foray into this topic. So I appreciate you joining us today all the way from Mexico to share your perspectives and knowledge and skills with us. I know you need to run and teach a class today. So I just want to pause and say thank you so much for joining this virtual exchange and telling us about quantum computing. If you can still hear me, I'll just give you a good big goodbye and wave on behalf of our students. Thank you so much. Excellent. Well, there you have it. You have a little bit of knowledge from an expert about the exciting world of quantum computing. It is an evolving field that incorporates a lot of the aspects of things that we've learned about on this virtual learning journey together. And if you have more interest in quantum computing and how it connects with research software engineering, or how quantum computing is used to solve some of our pending world problems, I would suggest you keep an eye on the newspapers and the news. I see quantum computing in the news all the time, and I think you'll see a lot more about it as you grow up and you experience the world and all the great things that Braulio and his colleagues are doing in this field. So with that, I'm going to say that is all the time we have for today. We have had such a great journey exploring this exciting world of supercomputing and research software engineering. I hope that you have learned a lot from Braulio today. I certainly have. It gives me lots to think about as it relates to computing. And also sort of how we think about the future of computing and how it impacts our everyday life. So special thank you to Dr. Braulio for that. And until the next time that we meet, I want to say goodbye and thank you for joining us. And make sure that you get a chance to check out Braulio's article on the Reach the World platform, which will tell you even more about his work and the exciting world of quantum computing. So thank you very much and goodbye for now.